Are you able to hear my voice?
Yes, sir.
Okay, okay, right. So this is the arrangement, and for this arrangement, if you draw the free body diagram, that is this is the ground, and we have mass M with this type of support as the roller, and here the relation that can be developed over here is the force is in this direction, and the other resistance for this dynamic loading is the stiffness, that is K is the stiffness. Okay, this stiffness is nothing but the elastic force. The material has the property in this, and it is multiplied with x displacement. Okay, stiffness into x, spring stiffness into displacement, and then the dampness. So the dampness is C into x dot. So what is this x? C into x dot. So damping constant into velocity. X dot is velocity, and x double dot will be acceleration, that I'll tell you later. So these are the forces, and here we also have the displacement x. So here the elastic force and inertia force is x m into x double dot, mass into acceleration. So this is the inertia force that will be developed in the material, and then the stiffness, which is multiplied with x, and the dampness, which is multiplied with velocity. So here these three are in one direction. So this is also mass into acceleration will be in the this particular minus x direction. If I say this is my plus x and this is my minus x, this is plus y and this is minus y. Let us say so nothing in y direction. They are in translation motion, so it is in x direction. All these terms are. So if you write the equation over here, m into x double dot is in one direction. So this plus c into x dot is in one direction, and k into x, these three are in one direction. Okay, and because of this force, so this is equals to p into t with respect to time. So all these three components, mass into acceleration, damping into velocity, and stiffness into displacement, are opposing this external force. Okay, so these are the internal parameter that will be calculated based on the type of structure. Okay, based on structure you will calculate this, and this P into T is the external force that will be applied onto this structure or onto these parameters. So once you apply this one, whether your structure is capable of withstanding this external force or not will be estimated. So this is the basic equation. This the equation of motion developed here is the basic equation. Now the same thing will represent with respect to a single story. Let us say that you have a single story and we'll develop the equation for the single story. Dynamic response of single story structure. Okay, so let us take a single story structure. So here what I'll do is that I will take a single story structure. Okay, and this is the mass m. This is the mass m, and this is the ground, and these are the columns. Say this is my column and this is my column. I know how to develop the equation for this one. Now this is the mass, and now the first component is that the force P of t or F of t with respect to time that is acting over here. Right. Yeah, right. P of t. This is the force. Now the internal parameters, what will happen? So this mass is going to oppose this force, right? This mass, whatever mass is there over here, m, that it is going to oppose this force, and the columns are also the stiffness that it is going to oppose the external force, right? The columns will not try to bend or give some, or it is going to give some resistance to the external force, that is P of t. So I can say that these are the stiffness. So this is K. I can say there are two columns, so I can say this one as K by 2 and K by 2. So total it is going to be K. Stiffness is going to be K. And the dampness, the material is going to have some dampness. So you can name this one like this. Something like this is nothing but the dampness C. So in detail, if you want to discuss about this dampness, I can say, and I can tell you with a simple example for that one. When you run on a floor, when you run on the level ground, it is easy for you to run faster. But if you want to run in a sand or beach run running chair, it is very difficult. Why? What is happening over there? There is dampness, that is the soil is very loose. Your footprint is going deeper, and it has to spend much, you have to spend much more energy from your body to what you call to go faster in the sand, on the sand. So that is called the dampness. And another example I can say that when you're going on a car or on a vehicle, when you go travel at around 60 kilometers per hour, if you're traveling, suddenly you can see some mud in between. What happens? That mud automatically will reduce your velocity. మీరు accelerate ఇచ్చినా సరే, it is going to take some more energy from your engine, and it is going to what you call, you have to spend much more energy on that particular material, because that is called the damping property. అండ్ ఇంకోటి మీరు చూసారా, ఊబ్ అంటాం. ఊబ్ అంటే ఏంటి? అది అదంతా ఏంటి? అది యాక్చువల్గా it has very heavy gravitational force inside that. It is nothing but you cannot come up because you don't have the grip over there. That is the dampness in that. Okay, so what happens is that it is going to absorb some part of energy. So here the materials also have a very minute dampness property. So we are not going to neglect that one also to get better results. Okay, sir, you can ask me another question, sir. Concrete lo dampness మనం ఎలాగా find out చేయొచ్చు అనేది? Yes, there is a dampness in concrete, in steel, and all the materials. If you take rubber is there, no? If you take that rubber, you can see that if you hit it, it is going to contrast and come back. That is the elastic property, right? That is a little bit dampness. It is going to observe that property will be there in that material. So like that, for the structures also there will be some dampness, and for concrete I think it is 0.25 is the dampness for the concrete, and for steel it is around 3.3 to 0.5 something. We'll see that what are the values accurately, we'll see. So these are the damping properties or the values that they can absorb. So whatever force is coming, which are given P of T, that force maybe 0.2% or 0.1% of the force can be absorbed by the material. Okay, that is called the dampness, right? So now this external force P of T will develop some displacement, as I have given in the earlier equation. It will develop some displacement, that is the x displacement of here, like this displacement. So what happens is that this structure will move like this up till here. Okay, and this stiffness of the column I will indicate with the other color. This column actually is going to move like this, and here also it is going to move like this. So this entire mass or a single story structure has been moved like this. Now if you draw the free body diagram for this one, how what are the forces that are going to act in the other directions? So here if you draw the free body diagram for this one, so I am just drawing this as a mass. This is my mass, and here this is getting displaced like this. So this is nothing but the stiffness K into X. This is my stiffness K into X plus 1. The next one is going to be my damping ratio C, okay, which I can write C into X dot. Okay. And the force over here is P into T, and the force for this force, external force, the force that is opposing is mass into acceleration. So this can be written as mass into acceleration plus C into X dot plus K into X is equals to P of T, the same equation. So in this equation, whatever we have found, the ground acceleration also will be there. So the mass of here is going to be mass into X double dot, whatever we have written, that will be modified as mass into acceleration plus x double dot g, ground acceleration. So this is this also will be there along with the mass. Okay, this also is going to give some resistance. So if you substitute this over here, so here this will be replaced with x double dot g. So the final equation is going to be mx double dot plus m double dot g plus c into x dot plus k into x equals to 0. So here m into x double dot plus c into x dot plus k into x equals to minus m x double dot g. So this is the equation for the single story building. Okay, so you have to remember this equation. You have to remember this equation very carefully. So with this, I'm going to stop the class over here. Okay.